This is an extension of the video covering how to run Jupyter Notebooks widget on Bwb. While that video uses new notebooks to display Jupyter working in the widgets, this video shows how to run existing notebooks, presumably made outside of Bwb, and import the notebooks to work in Bwb. Rather than focusing on Gitpod, this video will cover about when you are running Bwb locally on your system or device and trying to access and run your Jupyter notebook. The first thing you need to do is to make sure the files needed to run your notebook, especially any data and the notebook itself, is located somewhere within the Bwb work directory. If you started Bwb in your current working directory, make sure the files are located in that same directory somewhere. If they are located outside of Bwb's working directory, then the files cannot be seen in Bwb. Then, the next focus is opening up your notebook in Bwb. You can load up a Jupyter Notebook widget, click Export Graphics, and run it. This would take you to the Jupyter File Navigator. But there is a way to directly open your notebook from the widget. Go to the Optional Entries tab, enable the Notebook File entry, and locate your notebook. For this video, I have prepared two example notebooks, one in Python and the other in R, to show how to work with existing notebooks in Bwb. I will open the Python notebook first. As with getting notebooks to work on different platforms, there will be extra steps involving the libraries, packages, and other installations needed to get a notebook working in Bwb. For example, in the Python notebook, there are two packages imported at the beginning to plot this simple line graph. At the bottom, I have a line of code that was running the notebook locally outside of Bwb that lists the Python packages available when running the notebook the first time. In most cases, the packages imported will not be installed yet in the default Jupyter Notebooks widget, and you will need to install them into the widget. If you want to install Python packages at the start of the notebook, and every time you run the notebook from start to finish, you can do so by figuring out the packages needed to be installed and doing a pip install. In this example, NumPy and matplotlib are two packages needed. And to install them, you can add a new cell code block at the top of the notebook and include the following code: %, pip install NumPy matplotlib. Then the packages are installed for this kernel so that you can run the rest of the notebook using those packages. While this is good if you have a couple of packages, you could use a text file to list the packages you need to install. Ideally, the Python packages needed to run in the notebook are listed in a file called requirements.txt. This file is something you'll see when you try to set up a Python virtual environment, specifically when you are installing all required packages and their versions. But it is good to have this file for your notebook for the sake of reproducibility, especially if you want this notebook to run on other systems. In simple notebooks, the packages that are imported at the beginning of the notebook are listed in the text file, with each line dedicated to a package. And if you want to specify the version to install, you can do so by using the double equal sign and version after the package name. Once you have this requirements.txt file with the Python packages listed, there are two ways to install these packages. One way is to specify the installation directly at the beginning of the notebook. Much like the method shown earlier, this would mean every time you run the notebook from start to finish, the installation of the required packages will always be first. You can do so by putting the requirements.txt file in the same directory as the notebook file, which I have done already. Going back to the notebook, replace the two packages listed with -r requirements.txt. This installs the packages using pip and the text file. Then, when running the notebook, the packages are installed and the notebook runs all of its cells. However, this method works only for that session you are running the widget. If you restart the widget or reload the workflow, you will need to reinstall the packages again to make the notebook work again. You cannot skip the installation cell block when running the notebook again after restarting the widget. This is okay to do, especially if there are not many packages you need to install for the notebook, but the container running the widget will not save the installed packages the next time you run the widget. To circumvent this potential problem, the second way of installing these packages is by using this requirements file in the widget's Dockerfile and building an image with the packages already installed. Unlike the previous way, this installs the packages in a Docker image one time, eliminating the need to keep running the installation every time you run the notebook in a new widget session. This saves you time to not have to re-download everything again. To do so, open the widget editor for the Jupyter Notebook widget. Then navigate to the Docker tab and launch the Docker image builder. Open the Dockerfile, copy the requirements.txt file, and run the pip install on the requirements.txt file. Then save the Docker file. This will install the Python packages in the text file. However, this requirements.txt file would need to be in the same directory as this Docker file. If you want to add this file, then you can navigate to this workflow directory, then find the widgets directory, open the directory for the Jupyter Notebooks widget, open the Dockerfiles directory, and paste the requirements.txt file with the Docker file. Or you can copy the contents of requirements.txt, remove the contents of the Dockerfile code in the code block, and paste the packages onto the code block. Then save this code block as requirements.txt into the Dockerfiles directory. Let's load the Dockerfile again, and let's set up the Docker build for this widget version. You can call it Jupyter Packages 1.0. Then proceed to build an image. Once complete, change the image and tag to the one you just built. Save the widget and wait for the workflow to reload again. When you run the widget and get back to the notebook, you should be able to run the notebook with the required packages installed. And with this method, restarting the widget or the workflow will have the required packages ready to be used when running the widget again. Looking at the R notebook, ggplot2 is used to make a simple line graph. If you want to install the required R packages every time you run the Jupyter Notebooks widget, you can specify the libraries to install at the top of the notebook. The code to do so for this notebook is the following: install packages ggplot2. If there are more packages that need to be installed, you will need to make a vector of the packages instead. And if you want to find out the packages loaded for the notebook, run the notebook once outside of Bwb and run session info to see the packages and the other R information when running the notebook. Then, if you want to have these R packages pre-installed in a Docker image, you can change the Docker file to include the packages you want. Let's add this line of code at the bottom of the Docker file. Then, when setting a new tag for this image, let's say 2.0, you can build it and get the ggplot2 package installed. Testing to see if the package is pre-installed when running the widget again, you do not need to install the package at the beginning anymore. And once you are finished, you can shut down Jupyter to stop the widget. And by doing this method, ggplot2 will be already ready to go when starting the widget again.